Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robinson Ipulan, your partner in learning mathematics. But before you begin in this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. This time, we are going to review all the lessons that we've discussed in the previous week. In this video, I called it the interactive video materials. Every time I post a question, you may pause the video to answer it in your own and play it again to check the answers with me. In short, let's have an interactive video together. Okay? All problems solved in this video are the problems or questions in your Quipper assessments last week. Let's try to solve it together this time. Let's begin answering it together. So I have here, for Quipper assessments answered, number 1, the limitation of x sine x as x approaches to pi over 2. You may pause for now to answer the question. I do hope that you are done answering the question. So let's try to answer it all, together to check if you got it right. So the limitation of x sine x as x approaches to pi over 2. What are you going to do in this problem is to use direct substitution method. So it will become pi over 2 times sine pi over 2. Again, what they did is a direct substitution method. So after you substitute your x or the pi over 2 to all the x's in your problem, what are you going to do is to find the value or the exact value of sine pi over 2. Based on the table that I gave to you or that I presented to you, sine pi over 2 is equal to 1. Yes, that's right. Again, sine pi over 2 is equal to 1. Therefore, it will become pi over 2 times 1 because sine pi over 2 is equal to 1. And if you get the product of these two numbers, that is still pi over 2. Therefore, for problem number 1, the answer is, or the limitation of x sine x as x approaches to pi over 2 is pi over 2. Did you get it right? That's great. Let's continue mastering these skills. Okay? So I have here another problem in your one of the problem in your Quipper assessment last week. This is the limitation of tan 3x all over cotangent 2x minus secant squared x as your x approaches to pi over 4. You may pause the video for a while and answer the question. Okay, I do hope that you answered it already. Let's check if you get it right. So in this problem, you may use the direct substitution method, meaning you are going to substitute pi over 4 in all the x's or in all the variables in your function. So it will become tan 3 times pi over 4 all over cotangent 2 pi over 4 minus secant squared pi over 4. After you use the direct substitution method, you try to check if your problem has something to simplify. In this problem, there's nothing to simplify in this part, but in this part, there is something to simplify. We believe that we can able to find its least form or the simplest form. We can able to divide this one, 4 divided by 2, and that is 2. Therefore, for your cotangent, it will become pi over 2. So now, let's try to continue answering this one. So you can able to multiply this one, that is tangent 3 pi over 4 all over cotangent, it will become pi over 2 minus secant squared pi over 4. Since we are done simplifying all the terms in our trigonometric function, what we are going to do now is to find the exact value of these following trigonometric functions. We believe that tangent 3 pi over 4 is equal to negative 1. That's right. That is negative 1. Again, tangent 3 pi over 4, that is equal to negative 1. Cotangent pi over 2 is equal to, yes, that is 0 minus, you copy subtraction sign. And in this part, since we have two different second function, second pi over 4, what are you going to do is to simplify, find what is the value of second pi over 4. And the value of second pi over 4 is that? Very good. That is square root of 2. Since in your second you have squared, meaning you are also going to put squared in this part. Therefore, from trigonometric functions, you find the exact value with its regions. Therefore, it becomes like this. After you find the exact value of this following trigonometric functions, you are going to simplify in order for you to find the limit. And remember, that's the goal, to find the limit. So it will become -1 all over. We believe that we have squared here and we have also radical sign. In short, we can cancel this both. And what is remaining now is 2. -2, negative times +2, that is -2. And we believe we can still simplify our answer. Negative divided by negative, that is positive. Therefore, the limit now is 1/2. Again, in this problem, the limitation now is 1/2. Did you get it right? That's great! Let's continue mastering the skills in finding the limitation of trigonometric functions. I have here my third problem, one of the problems in your Quipper assessment last week. The problem is the limitation of x squared cosecant x as x approaches to pi over 4. So now, you may pause the video for a while and try to answer it in your own. Okay, I do hope that you already answered the problem. Let's check if you get it right. So the problem is x squared cosine x as x approaches to pi over 4. Same thing in our example 1 and 2. We can able to use the direct substitution method. In short, we are going to substitute where your x approaches to all the x's in your function. So it will become, I have x here, so that is pi over 4 squared cosine pi over 4. Again, we simply substitute where our x approaches to all the variables in our functions. And it becomes like this. After you simplify, or after you substitute, or you use the direct substitution method, what are we going to do now is to simplify our function. First is, you find the exact value of your trigonometric function. And I have your cosine pi over 2. And the exact value for that one is square root of 2 over 2. Check your table if you got it right. And now, we try to simplify this one. We believe that it is a fraction where we have squared. In short, we can able to distribute squared both numerator and denominator. It will become now pi squared over 4 squared. What we did is we simply distribute the squared in numerator and denominator. After we find the exact value of cosine and we simplify this one, let's try to simplify it here. We keep on simplifying for us to find the limit. So, very obvious, we have to fraction in multiplication operation. What we did in that part is we simply multiply numerator to numerator and denominator to denominator. So, pi squared times square root of 2, that is pi squared square root of 2. All over, we have 4 squared here and we have 2. We believe that 4 squared is equivalent to, yes, that is 16. And 16 times 2, that is 32. Very good. In short, the limit of our function is pi squared square root of 2 all over 32. Did you get it right? That's great! Let's continue answering the Quipper assessment. We are down to problem number 4. And our problem is the limitation of sine quantity x squared plus pi all over 2 as your x approaches to 0. You may pause the video for now to answer it in your own. I do hope that you already answered it in your own, and let's try to check if you got it right. So in this problem, I have a function sine x squared plus pi all over 2 as my x approaches to 0. What's the best way to solve this one? By using still the direct substitution method. Once you use the direct substitution method, it will become sine 0 squared plus pi all over 2. Since we already have one variable and that is x squared, meaning we can only substitute 0 in that variable. After we substitute, we keep on simplifying, and we believe 0 squared is 0. What is left now is sine pi over 2, because 0 plus pi, that is still pi over 2. After that one, as you can observe, we only have a sine pi over 2. The best way to find the limit is to find the exact value of sine pi over 2. What is the exact value of sine pi over 2? Very good. That is 1. Therefore, the limit of this function is 1. Simple as that. Did you get it right? That's great. Let's continue mastering trigonometric function, or the limit of trigonometric function. We are down to the example number 5. And the question is, the limitation of 1 over cosine x as x approaches to 0. You may pause the video for now and answer it in your own. I do hope you are done answering the problem. So now, let's try to answer this one. Let's check if you got it right. That is limitation of 1 over cosine x as x approaches to 0. Is direct substitution the best way in solving this problem? Yes. Why? Because once you substitute x here, it will not become undefined. Because cosine 0 has a value that is not 0. So meaning, direct substitution is the best way to solve this problem. And it will become 1 over cosine 0. And we believe cosine 0 is equal to 1. That's great. So that is 1 over 1. And 1 over 1, that is 1. Therefore, the answer for this problem is 1. Did you get it right? Very good. That's great. Let's try to answer this problem. We are down to example number 6. And this problem looks like this. The limitation of x cotangent x as x approaches to 0. You may pause the video for a while and answer it in your own. I do hope that you already answered it in your own. Let's try to check if you got it right. In this problem, x cotangent x as x approaches to 0. What is the best way to solve this one? Is direct substitution the best way to solve this problem? No. Because once we use direct substitution in this problem, cotangent 0 is undefined. You may check the table. That is undefined. Meaning, in our experience, once we encounter problem whose limit is undefined, we are not there to conclude directly that the limit does not exist. Because we keep on simplifying the problem, let's try to check if we can able to see some ways to find its limit. In this problem, what are we going to do is to try to simplify this one. We try to find ways in order to find its limit. Meaning, let's find what is other values of cotangent. We believe that cotangent is the cofunction of, or the inverse of, tangent function. Tangent x. And we believe the tangent x is equivalent to, in the function of cosine and sine, that is sine x over cosine x. And we believe that tangent x and cotangent x are inverse to each other. In short, for me to find the cotangent x, its sine and cosine function, we have to get the inverse of the value of tangent, and that is cosine x over sine x. In short, cotangent x is equivalent to cosine x over sine x. Meaning it will become x cosine x over sine x. Limitation, as x approaches to 0. We simply find the equivalent, and that is cosine and sine x. After we do that one, let's try to find ways where we can use all the limit theorems in finding the trigonometric function. Can we interchange the position of x and cosine x? Yes. We can able to interchange their position simply because this is a multiplication, meaning they are commutative. It will become limitation of cosine x times x over sine x as x approaches to 0. Are these two equal? Yes. We simply interchange the position of cosine and x. That is still the same because multiplication is commutative in nature. So meaning, after we do that one, we try to use direct substitution if we can able to find its limit. What is the limitation of cosine x as x approaches to 0? It will become cosine 0. Does cosine 0 has a value? Yes. Cosine 0 is equal to 1, meaning it has a value. Copy multiplication. What is the limitation of x over sine x as x approaches to 0? Do we have a value for that one? Exactly yes, because this is one of the special limit theorems of trigonometric function. The limit of x over sine x as x approaches to 0, again, that is a special limit theorem of trigonometric function. And the value for that one is 1. Very good. So meaning, limitation of x over sine x as x approaches to 0, that is 1. And 1 times 1, that is 1. Therefore, the limitation of this problem x cotangent x as x approaches to 0 is equal to 1. What we did is we keep in simplifying until such time we find its limit. Did you get it right? Very good. That's great. We keep on practicing for us to master the skills of the limits of trigonometric function. I have here my question number 7, still one of the question in your Quipper assessments last week. The question is, what is the limitation of sine cube 3x all over x cubed as x approaches to 0? You may pause the video for a while and try to answer it in your own. I do hope that you already answer it in your own. Let's try to check if you get it right. The problem is this one. The limitation of sine cube 3x as all over x cubed as x approaches to 0. Is direct substitution helpful in solving this problem? No. Simply because once you use direct substitution, your denominator will become 0 and that is undefined. Every time we encounter an undefined function, we are not there to conclude directly that the limit does not exist. What we usually do is to find ways in order to find its limit. As you can observe, the numerator is a perfect cube, and our denominator is also a perfect cube. So since they are both perfect cube, we can able to write it this way. That is sine 3x all over x raised to the power of 3. Limitation as x approaches to 0. Is this 2 equal? Yes. Because once we encounter this one, we distribute the power, both numerator and denominator. Meaning, they are equal. And now, after we converted this version into this version, let's try what is the best way to solve this one. We believe that this is similar to the limitation of sine x over x as x approaches to 0, that is 1. Meaning, we can able to use this theorem in solving this one. In short, we find ways in making our denominator equal to 3x. And the best way to do that one is to multiply whatever inside this power into 3 over 3. Okay? Let's try to have some space. Okay. So, since we are here to use this theorem, meaning we lock 3 in our denominator. What we usually do in solving that one is we multiply 3 over 3. Because we need 3 here, right? Is this mathematically correct? Yes. Because 3 over 3, that is 1. And we have always 1 beside any function. So what are we going to do now, right now is to simplify this one. So it will become limitation of sine 3x times 3, that is, very good, that is 3 sine 3x. Again, do not multiply 3 inside your sine function. What is the best way to do is to put 3 beside. The best way is to put it beside sine 3x. 3 times x, that is 3x. Raised to the power of 3. So as you can observe, we can able now to use this theorem by separating this one. Okay? Let me get my eraser. Okay, let me continue in this part. Since we can able to separate, since we can able to separate this one in this form as 3 times sine 3x over 3x, right? So let's try to find the limit as x approaches to 0. So it will become now the limitation of 3 times sine 3x over 3x raised to the power of 3 as x approaches to 0. So let's try to find the limit. What is the limit of 3 as x approaches to 0? Very good. That is 3 using the constant rule. What is the limitation of sine 3x over 3x as x approaches to 0? Yes, that is the special limit theorem, and that is equal to 1. And we believe we still have power inside, outside our function. So 3 times 1, that is 3 cubed. And 3 cubed, that is 27. Therefore, the limit of this function is 27. Did you get it right? That's great. Continue practicing.